Hi students, this is another question for helical gear. In this case, the diameter is unknown. So how we can design a helical gear without knowing the diameter? So we can study how we can study these kinds of problems also. So I can read the question. A helical cast steel with a 30-degree helix angle has to transmit 35 kilowatt at 1500 rpm. If the gear has 24 teeth, determine the necessary module, pitch diameter, and phase width for 20-degree full depth teeth. The static stress for cast steel may be taken as 56 megapascal. The width of the face may be taken as 3 times the normal pitch. What would be the end thrust of the gear? And the question is continuing. The tooth factor for 20-degree full depth involute gears are taken as 0.154 minus 0.912 divided by ZE. The value of Y they are directly given in the question itself, where ZE is the equivalent number of teeth that we are used for a helical gear. We know that, and we can write the given data. That is helix angle they are given, that is equal to 30 degree. The power that is equal to 35 kilowatt, and the speed of the pinion, that is N1 is equal to 1500 rpm. Number of teeth on pinion, that is Z1 they are given, that is 24, and alpha is 30 degree involute. Then B, that they are given as a condition, that is equal to 3 into Pn, and sigma D1 and sigma D2 both are same, that is equal to 56 megapascal. And the value of Y is not directly taken from the data book, it is directly given in the question itself. So you can take that value from the question. And they ask about the module and the phase width, then the end thrust we can denote it as Ft. Then next, first one we can identify the weaker part. The weaker part using the strength factor. Here the value for this sigma D and Y will be same, because the value, that is the material, the material for the gear and pinion are same. So we can identify that the gear is the pinion is a weaker one. Both we can write it as, since both pinion and gear are made of same material, the pinion is weaker. So we can conclude this conclude the first section, that is hence the design is based on only on pinion. Then next, Virtual number of teeth. We can calculate the virtual number of teeth using this equation. Z is equal to Z by cos cube beta. From that equation we can calculate, we will get the value of ZE1 is equal to 37. Then next one is the module. Module we can calculate using this equation. Using this equation, that is 12.60 Mn, that is equal to we can use this equation, cube root of 2mt Cw cos beta divided by sigma d Cv by Cv ky into Z, and we can calculate the value of mt. So if the diameter is unknown, we can use this equation from the data book. So please underline this section, that is if the diameter is unknown value, we should use this equation, and here the power is given also. Power is given, so we can calculate the value of mt from using that equation. P is equal to 2 pi nt by 60, and now we will get mt is equal to 228 into 10.82 in Newton meter. We can convert it into millimeter. The value of B is given as a 3 into Pn, that is in the given data. So we do not assume any value for K. Take the direct value of K is equal to 3 into Pn divided by Mn. But we know that Pn is equal to pi into Mn cos beta from this equation, that is 12.43. Using that equation we can take the value of K is equal to 3 pi. So if in this case the value of K we cannot assume, because it is directly given in the question itself. Then next one, assume value of Cv. V is not given, or N1 is not given, so we can directly take the value Cv is equal to 0.5. We can assume this the value. Then Cw we already know, using the table 12.21 we can assume that the value of Cw is equal to 1.15. Then the form factor Y is equal to pi into Y1. So using these values we can find the value of Mn. Okay, using your calculator find the value of Mn. So the value of Mn will become 5.57. Then using table 12.2 we can standardize the value of module. Mn is equal to 6 mm. Once we get the Mn value, then we can go for PCD, that is D1 and D2. we can find the value of d1 using this equation, mn into z1 divided by cos beta. It is already given in the data book 12.47. I can show that is 12.47 equation number. So using this equation you can find the value of d1. Then phase width, the question itself they given that b is equal to 3 into pn. So using this equation we know that pn is equal to pi into mn. So using this equation we can find the value of phase width. Next we can check phase width, that is the sorry, the value calculated is safe or not. So using this equation, that is 12.54, we can take check the value, that is safe or not. That is b min is equal to 1.15 into pi into mn divided by sine beta. So using this equation, that is we will get the value of b minimum is equal to 43.35. So we can conclude this step as b, the calculated value using that previous case is b greater than b minimum. So the value taken are safe. So next we can go for next section. That is we can assume the value of CV. We can check now sigma d is safe or not. That is ft is equal to, we know that ft is equal to sigma d into CV into, it is already given in the data book. So equation number 12.59, you write this equation, and the value of v, that is n1 is, using that n1 we can take the value v is equal to 13.15. From that equation take the value of CV is equal to 15.25 divided by 15.25 plus v, and this value is 0.5361. In case of this is used because the diameter is unknown, so we are using this method. And next we can calculate ft is equal to 2mt divided by d. It is already given in equation number 12.22. Then using this equation we will get ft is equal to 2652.62 Newton. Then we can check sigma d. Sigma d here is 41 megapascal. Then using this equation and using your calculator you will get the value of sigma d, that is equal to 41 megapascal. Which is less than the permissible value. We take the permissible value, or in our question that given value is 56 megapascal, but the calculated value is 41 megapascal with our design parameters. So our design are safe. Then next we can go for a axial thrust or thrust force. We can denote it as FA, that is equal to FT into tan beta. That is equation number 12.51. Using this equation we can find the value of axial thrust also. So thus we can conclude this question. Okay, thank you.